If I got this question on a test, I would just close my eyes, pick one, and hope for the best. But since this is not a test and I'm supposed to be teaching you how to do these, let's go ahead and get it done. So the first function is linear. So I know that it would only need to go out to the first degree of commonality. So let me build a table. If you enjoy these, and I do enjoy them, I have to say, but this is the problem for you if you enjoy these problems. All right, so we have an x and a y, and then I need to leave some space for the work, and then I'll leave some space for the common consecutive difference, or we'll say consecutive difference. All right, so here's x and here's y. I am only going to choose 4 values for these. I think that'll be enough to tell us what we need. And the first function is f of x equals 3x plus 5. So I'm going to choose negative 1, 0, 1, and 2. Now I'm going to copy this so that my video is not so incredibly long with me having to do draw these, but you can pause the video anytime you need to. All right, so here we go. We're going to evaluate this function. So when x is negative 1, I would get negative 3 plus 5, and that is positive 2. So y is 2. When x is 0, I don't even have to work this one because there's baby b. That's going to be this value. I am going to put it right here, though, because I'll need it in a minute. So when x is positive 1, I get 3 times 1 plus 5 is 3 plus 5. That's positive 8. And then when x is 2, we'll get 3 times 2 plus 5. That's 6 plus 5 for positive 11. So this will be 5 minus 2 is 3. 11 minus, that'll make a difference. 8 minus 5 is 3. And 11 minus 8 is 3. So this is common. The common consecutive difference is 3. And we're looking for a negative 6, so it's not option A. All right, so let's plug this one in. Again, if you need to stop your video and draw, that's fine. But this time we have a negative 3x plus 5. So all they changed was the negative sign. So let's do the substitution. I can tell you that 0 is still going to pair up with 5. All right, so f of negative 1 will be negative 3 times negative 1 plus 5. So that's positive 3 plus 8 plus 5 is 8. Then f of positive 1 is negative 3 times positive 1 plus 5 is negative 3 plus 5, which is 2. And then f of positive 2 is going to be negative 3 times positive 2 plus 5. and that's going to be negative 6 plus 5 is negative 1. Then let's do consecutive differences. So I have 5 minus 8 is negative 3. 2 minus 5 is negative 3. 1 minus 2, negative 1 minus 2 is negative 3. So the common consecutive difference is negative 3. We are looking for negative 6. So that is not the one I want. It is common. It's just not negative 6. Okay. Let me move this over as far as I can. Let me do it this way because we'll get all tripped up, or I will. Okay, I'm going to draw a table for a quadratic. So we need to have space for 2 levels of consecutive differences. So it's going to look pretty much the same, just a little bit bigger. And I'll have a column for X and Y. Then a column for my math. A column for first and second levels of differences. And I think I'll just make a copy of this one again. This is consecutive difference 1 and consecutive difference 2. And I will expect commonality at 2 because the function is f of x equals 3x squared plus 5. And I'm going to use those same values of x because they're small. I can tell you that plus 5 goes with 0. And let me make a copy of this picture. That'll save a little time. All right, let's do some math. So we have f of negative 1 will be 3 times negative 1 squared plus 5. So that's 3 times positive 1 plus 5. That is going to be 8. 3 plus 5 is 8. Then we know that intercept one. So f of positive 1 is 3 times 1 squared plus 5. That's 3 times 1 plus 5 is 8. And then f of 2 will be 3 times 2 squared plus 5. So that's going to be 3 times 4, that's 12, plus 5 is 17. So consecutive differences will be 5 minus 8, negative 3. 8 minus 5 is positive 3. And then 17 minus 8 is 9. So it is not common at this level, but I would not have expected it to be. Then I have 3 minus negative 3. That's positive 6. Then 9 minus positive 3 is positive 6. So this is a common consecutive difference of positive 6. And that is not what we're looking for. We are looking for negative 6. Wouldn't you know it's not what we're looking for? All right, so let's try this again. Feel free to pause the video while I erase out this function and put in the next one, which is f of x equals 3x squared plus 8x plus 5. And again, plus 5 is my y-intercept. So f of negative 1 will be 3 times negative 1 squared plus 8 times negative 1 plus 5. And that's going to be 3 minus 8 plus 5. And that will be 3. Then f of 1 is 3 times 1 squared plus 8 times 1 plus 5 is 3 times 1, that's 3 plus 8 plus 5. So that is 13 plus 3 is 16, I do believe. And then f of 2 will be 3 times 2 squared plus 8 times 2 plus 5. That's 3 times 4, or 12, plus 16 plus 5. So that is 28 plus 5 is 33. Right? 8, 9, yeah. Okay. Is that right? 28, yes, 28 plus 5 is 33. Sorry, guys. All right, first consecutive difference. That's 2. 16 minus 5 is 11. And 33 minus 16 is 17. Not common, but I wouldn't have expected it to be. This is quadratic. So then I have 11 minus 2. That's 9. 17 minus 11 is 16. So I have either made a mistake or this is not a quadratic function. Let me look back through it. Actually, let me look at the answers, because that's going to tell me if it's me or them. This is number, what, 9. The answer is E. So it could be that I have made a mistake in my math. I think what I'm going to do off camera is just go back and take a look at this. I'll check it off camera. And if there is a problem, I'll come back and let you know. But the answer we're looking for is E. So let's go ahead and plug this one in and see what we get. Negative 3x minus 14 plus 5. So negative 3x squared minus 14 x plus 5. So that y-intercept hasn't changed. All right, here comes f of negative 1. So that's going to be negative 3 times negative 1 squared minus 14 times negative 1 plus 5. So that will be positive 3, positive 14, positive 5. And I'll tell you what I'm going to have to do to make this fit. I'm going to remove the function part, the f of whatever, and just do the substituting because I don't have enough room. So this one looks like 17 and 5, that's 22. This one we already know was 5. Okay, so 22 would be the y for this one. And then here we have negative 3 times 1 squared minus 14 times 1 plus 5. So negative 3 times, I messed up. Sorry. I'm going to stop after this one, guys. I am too tired. Here is my mistake. Negative 3 times positive 1 would be a negative 3. So let's take that out and redo that. So we have, what, 16? Let me type that in my calculator now that we're all thoroughly confused. I'm sorry. 18. Yes. No, that's not 18. That's 16. It has to be. 3 negative plus 14 plus 5 is 16. I swear I got 18 out of my calculator. So who knows what I typed in? Let me take a deep breath and say how much I hate this problem. But we can do it. All right, down here I have negative 3 times positive 1 is negative 3. Minus 14 plus 5 is 12 negative, I believe. But let me make sure. Yes. And then finally, when x is negative 2, we have negative 3 times 2 squared minus 14 times 2 plus 5. So we have negative 3 times positive 4 is negative 12 minus 28 plus 5. 12 negative minus 28, add 5, is negative 35. Unless I've done something else crazy. So this would be 5 minus 16. That's going to be negative 11. 12 minus 5 is negative 17. And then 35 negative minus 12 negative is going to be something I'm not even going to try. Negative 23. Then negative 17 minus negative 11, finally, is negative 6. Negative 23 minus negative 17 is also negative 6. So it is common at the second level at negative 6. And that is the one we're looking for. Man, I don't often say that I hate a math problem, but I hate that one. And I'm going to check option D off camera, and then I'll come back with a clip to explain what I found.